Good evening, students. Today we are going to continue with mole concept exercise 5B numericals from 16th question. What is given here? Calculate number of atoms in 52 moles helium or 52 atomic mass unit of helium or 52 grams of helium. So these are the three things what you need to calculate. First and foremost thing they have mentioned here, how many number of atoms are there in 52 moles of helium. So we know that if you are taking 1 mole, which is equivalent to Avogadro number 6.023 into 10 to the power of 23 atoms of helium. So this is very clear, we know this already. Now they are asking for how many moles? They are asking for 52 moles. So for 52 moles, take it as x and cross multiply. X is equal to 52 into 6.023 into 10 to the power of 23. Hope you have understood this. I have calculated this earlier and I got around 313 into 10 to the power of 23 atoms. So to write in scientific notation, we can take it as 3.13 now into 10 to the power of 25 atoms. Hope you have understood this. So x value will be 3.13 into 10 to the power of 25 atoms. So 1 mole we have, so 52 moles I have calculated. So make a note of this. Now try to solve the next question, that is B, 16B. They have mentioned here atomic mass unit. Earlier we know about the moles and the mass, but now what is the relation between atomic mass unit and gram? It is nothing but 1 atomic mass unit is equal to 1.66 into 10 to the power of minus 24 gram. So using this relation we can find out the mass, and later with the mass you can find the number of atoms. So how many atomic mass units are given? 52 atomic mass unit. Take it as x, cross multiply. X is equal to 1.66 into 10 to the power of minus 24 into 52 grams. So this is the mass what you got here. So how much mass of helium is there? You can write like this. The mass of helium what you have is 1.66 into 10 power minus 24 into 52 grams. Later we know that 1 mole of helium is nothing but 4 grams, and Avogadro number, that is nothing but 6.023 into 10 to the power of 23 atoms. So this is clear to us what we have learnt earlier. Now how much gram you have? 1.66 into 10 to the power of minus 24 into 52. So find out how many atoms are there as x. Now we have 4x, you know, so therefore x is equal to 6.023 into 10 to the power of 23 into this will be 1.66 into 10 to the power of minus 24 into 52. So 4x was there, so now x is equal to, we can take in the denominator 4. Hope you have understood this. Next, so you can cancel this. So on multiplication, this into this, we have 10. So 10 into, this is 10 to the power of 23 into 10 to the power of minus 24 into 52 by 4. Hope you have understood this simple calculation. On multiplying this you get 10. Now this is 10 to the power of 24 and 10 to the power of minus 24 gets cancelled out, and what you have 52 by 4, nothing but 13 atoms. So make a note of this. So 52 atomic mass unit of helium is equivalent to how many atoms? 13 atoms. So write down. Now easily you can solve 52 grams of helium. So see, we can write here. You know that number of atoms, if you take 4 grams of helium, that is 1 mole, Avogadro number is 6.023 into 10 to the power of 23 atoms. But what they have mentioned here, they have mentioned 52 grams of helium, how many atoms are present, by taking it as x cross multiply. Now x is equal to 6.023 into 10 power 23. This we will multiply, so into 52, and 4x was there, so here it will become divided by 4. So now you can cancel this 4 ones and 4 13s. So 13 into 6.023 into 10 to the power of 23. So I have calculated this earlier, nothing but 7.8 you will get. So 7.828 into 10 to the power of 24 atoms. So make a note of this. Let us move to question number 17. Now question number 17. Calculate number of atoms of each kind in 5.3 grams of sodium carbonate. The formula is Na2CO3. They are asking find out the atoms of sodium, carbon as well as oxygen separately. For that, let us see like this. So for sodium carbonate, if you are taking 1 mole, so the mass, how to calculate that? You know the molecular mass you can calculate, nothing but 23 into 2 for sodium. This is for sodium. We can write sodium atomic mass 23, carbon is 12, oxygen is 16. So using this you can easily calculate the mass of 1 mole of sodium carbonate. Now for carbon you know that it is 12. So let us write 12, only one atom is there. Here it is 2 atoms of sodium, 1 atom of carbon. Next oxygen, we have 3 atoms. 16 into 3, nothing but 48. So totally you are getting 106 grams. So 1 mole of sodium carbonate weighs 106 grams. So you can write like this. 1 mole is 106 grams. Now they have 5.3 grams. So you need to calculate this. So X, how to calculate X? So 106x is 5.3. Therefore X is equal to 5.3 by 106. Nothing but 0.05 mole. You can solve it. Slowly you solve it, you will get the same answer, 0.05 mole. So finally what we understand here, if you take 5.3 grams of sodium carbonate, it has 0.05 mole. First step we have calculated this. Now after calculating this, you need to find out how many number of atoms are there. Now in sodium carbonate, which is 0.05 mole, first one, number of sodium atoms. So we can easily find out how to write that. So 1 mole Na2CO3, if you consider in that, we can write it as Avogadro number 6.023 into 10 to the power of 23 into 2 sodium atoms are present. Why you have written into 2? Because here we have Na is 2, atomicity is 2. Fine. Now for 0.05 mole of sodium carbonate, how many are there here? Take it as X, cross multiply now. X is equal to 6.023 into 10 to the power of 23 into 2 into 0.05. Hope you are able to follow this. Now if you take this one, if you multiply, you will get this is 0.1. So 6.023 into 10 to the power of 23 into 0.1. So you know this 0.1 is nothing but 1 by 10. So 1 by 10 and 10 to the power of 23, finally you can write like this, 6.023 into 10 to the power of 22 atoms of sodium. So we can write 0.05 mole sodium carbonate contains this many number of atoms of sodium. Hope you have understood this. Follow the same principle and you can calculate number of carbons also. Second one, number of carbon atoms. See, to calculate number of carbon atoms, you can take like this, 1 mole Na2CO3 is equal to 6.023 into 10 to the power of 23 into, what is atomicity here? Na2CO3 only 1 carbon, therefore atomicity is 1, you can put into 1. 0.05 mole, take it as X, cross multiply. So X is equal to 6.023 into 10 to the power of 23 into 1 into 0.05. So Answer will be 3.01 into 10 to the power of 22 atoms. So I have calculated earlier, hence we have written like this. So number of atoms of carbon. So make a note of this. Using the same method, you can calculate number of oxygen atoms also. So how many moles you got? 0.05. So we can write like this. 1 mole Na2CO3. So now we are talking about oxygen. Atomicity is 3, number of atoms are 3. Therefore, 6.023 into 10 to the power of 23 atoms into 3. Into 3 atoms of oxygen. Hope you have understood this, very simple. Now if you take 0.05 mole, take it as x, cross multiply. So x will be equivalent to this into this. 0.05 into 6.023 into 10 to the power of 23 into 3. So if you take exact value, you will get 9.03 into 10 to the power of 22 atoms. So 22 atoms of oxygen. So we can write like this: 0.05 mole of sodium carbonate contains this many number of atoms of oxygen. So make a note of this, and next we'll move to question number 18. Next, let us solve question number 18. Calculate mass of nitrogen supplied to the soil by 5 kg of urea. You know the formula of urea. So we have like this: CONH2, amide linkage, and NH2. So the whole thing can be written like this: CONH2 taken twice, also urea formula. They have given the atomic mass also individually: oxygen, nitrogen, carbon, and hydrogen. So first let us solve A. So if you observe this CONH2 taken twice, that is urea. If I want to know the molecular mass of urea, let me calculate like this: carbon is 12 and oxygen is 16, and NH2, if you calculate, it is nothing but 14 plus 2, 16, 16 into 2, 32, plus 32. So we get 60 grams of urea. So molecular mass of urea is 60 grams. In that, how many grams of nitrogen are there? So N2 is nothing but 14 into 2, so 28 grams. So we can write like this: 28 grams of nitrogen is present in 60 grams of urea. So this is standard thing. From the molecular mass, you got how much amount of nitrogen is present in 60 grams of urea. Next, in the given question, they are asking in 5 kg of urea, how much nitrogen is present. So let us write like this: if you take 60 grams urea has 28 grams of nitrogen. Now they mentioned 5 kg, so we can write like this: 5 into 10 to the power of 3 grams of urea, nothing but 5 kg. Take it as x, cross multiply, what we get: 60x, 60 into x is equal to 5 into 10 to the power of 3 into 28. So hope you have understood this cross multiplication. Now x is equal to 5 into 10 cube into 28 divided by 60. Hope you have understood. This is nothing but 5 kg. 5 kg we have written in terms of grams because urea is also measured in terms of grams. Both should be in the same unit. Now x. Let us find out this. So if you calculate, finally you will get 2.33 kg. I have already calculated for you, so hence the final answer will be in kg, nothing but 2.33 kg. Hope you have understood this. We can write like this: final statement: 2.33 kg of nitrogen is present in 5 kg urea. So this is your statement. Make a note of this. Very simple. First you have calculated the molecular mass of urea as 60 gram. In that you have 28 grams of nitrogen. But in the given question, they have 5 kg of urea, nothing but 5 into 10 cube grams. For that, how much will be there? Nothing but on calculation you get 2.33 kg. Now second one, you try to solve this. So volume occupied by 320 grams of sulfur dioxide. So sulfur dioxide, you can write the formula SO2. So in solution B, what we write? Always calculate the molecular mass. Sulfur they have 32 and O2 is nothing but 16 into 2, again 32. So we get 64 grams of sulfur dioxide. So how much quantity they have given? They have given 64 grams of this. Now, as you know, the 1 molar molecular mass of any gas, 64 grams of SO2, the molecular mass is mentioned, or 1 mole occupies 22.4 liters volume. So this is already known to us. Now they are asking find the volume occupied by 320 grams. Therefore, volume occupied by 320 grams of sulfur dioxide. So let us take it like this. So 320 grams of sulfur dioxide. Calculate the volume as X here. Now X 64X is equal to 22.4 liters into 320. Hope you have understood this. Now X is equal to 22.4 into 320 by 64. So taking 16, we can write like this. 16 into 4 and 16 20. So 4 ones and 4 fives. So 5 you got. 5 fours 20. 5 is 10, 12. So here we got 5 to 10 and 11, nothing but 112.0. So therefore, volume occupied by 320 grams SO2 is nothing but 112 liters. So make a note of this answer. Now let us move to question number 19. Hope you have understood this. Now question number 19, so we can take both 19 and 20 together. Atomic mass of chlorine is 35.5, calculate the vapor density. So we have a relation between molecular mass and vapor density. So molecular mass is nothing but 2 into vapor density, we can write it as Vd. So apply this formula and you can calculate the answer for this. So if you take chlorine Cl2, its molecular mass is equal to nothing but atomic mass is 35.5, but here you are having 2 atoms, so therefore 35.5 into 2, nothing but 71. So 71 atomic mass unit or 71 unified mass. Substitute this here, therefore molecular mass 71 is equal to 2 into vapor density. Now send 2 to other side. 71 by 2 is nothing but vapor density of chlorine. So therefore it is nothing but 35.5. So what you can write here? We can write it as the vapor density of chlorine is calculated as 35.5. Hope you have understood the question number 19. Now let me write the solution of question number 20 here. What is the mass of 56 centimeter cube? Nothing but they have given volume of carbon monoxide at STP. First and foremost thing, if you take 1 mole of CO, how much you will get? C is 12, oxygen is 16. Hope you are able to understand we are writing the molecular mass so that it will occupy 22.4 liters. So this is nothing but, here it is 28. So we can write like this. 28 grams of carbon monoxide occupies 22.4 liters here. So I think you have understood this. If you calculate the molecular mass, it will be like this, 28 grams. So 28 grams will occupy 22.4 liters. But here they have taken in centimeter cube, therefore we can write like this. 28 grams of CO occupies volume of 22,400 centimeter cube. I have converted liter into centimeter cube. Now the question is very simple. they have mentioned 56 centimeter cube. 56 centimeter cube, what will be the mass? So let us take the mass as x. Now cross multiply. What we get? 22,400 x is equal to 56 into 28. Therefore x is equal to this. On the other side, if you take, it comes in the denominator 22,400. I have already calculated this. This will be 0.07 grams. X is equal to 0.07. So we can write like this. Therefore, mass of CO is equal to 0.07 grams. So which occupies 56 centimeter cube volume. Okay. So how much mass will occupy 56 centimeter cube volume? Nothing but 0.07 grams. Hope you have understood this. Make a note of question number 19 and 20. Let us move to question number 21. Now try to solve question number 21. They have mentioned determine number of molecules in a small drop of water which weighs 0.09 grams. First and foremost thing, what is the molecular mass of water? So if you calculate this, 2 plus 16, nothing but you will get 18 grams. So according to this, we know that 18 grams of water has Avogadro number 6.023 into 10 to the power of 23 molecules. So this we know. Now, what is given? They have asked here 0.09 grams water. Now let us convert it into this. 0.09 can also be written as 9 into 10 to the power of minus 2 grams. So 9 into 10 to the power of minus 2 grams of water has how many molecules? So that is the question. Hope you have understood this. Now on cross multiplication we get 18x is equal to 9 into 10 to the power of minus 2, this into 6.023 into 10 to the power of 23. Now x is equal to 9 into 10 to the power of minus 2 into 6.023 into 10 to the power of 23. Now this is 18 into x. Now it will become divided by 18. So 9 ones and 9 twos. So with the 2 we can cancel this. 2, 3, 6, 0, 1 and 1. So 3.011 we will get. This is 10 to the power of minus 2. This is 10 to the power of plus 23. So 23 minus 2 will be 21. So we get x is equal to 3.011 into 10 to the power of 21 molecules. So hope you have understood this. Finally, what will be the answer? Number of molecules present in 0.09 grams water, nothing but x. So you can take it as 3.011 into 10 to the power of 21. So hope you have understood question number 21. So make a note of this and let's move to question number 22. So all these questions we are applying the same thing, that is the molecular mass is equal to 1 mole is equal to Avogadro number of any particle. It may be molecules, ions or atoms. Move to the next question. Now question number 22. The molecular formula for elemental sulfur is S8. So we have 8 atoms of sulfur. Sample you have around 5.12 grams. They are asking number of moles as well as how many molecules and how many atoms are present. Let us solve step by step. First one, how do we calculate the moles here? Number 1, if you are taking S8, you take in this the molecular mass. Molecular mass can be calculated. Sulfur, 32. So therefore 32 into 8 grams. So the molecular mass, gram molecular mass, if you take it is 32 into 8. Now what is given? 5.12. So this particular molecular mass has 6.023 into 10 to the power of 23 molecules. So this Avogadro number. So 32 into 8 grams is this many number of molecules, or you can calculate it as 1 mole also. So nothing but it is equivalent to 1 mole. Now 5.12 grams they have mentioned. So let us calculate. 5.12 grams is equal to, they are asking in terms of mole, so let us calculate in terms of mole. So on cross multiplication, what we get? 32 into 8x, so is equivalent to 5.12. Hope you have understood this. If you don't want to write molecules, you can ignore this and write only 1 mole. Therefore x is equal to 5.12. Now this is multiplication here, so on the other side of equal symbol it will become denominator 32 into 8. So I have already calculated 0.02 moles we get. So first one, how many moles of sulfur are present here? 0.02 moles. So I think you have understood the first question. First you find out the molecular mass. The molecular mass is 32 into 8. So this is equivalent to 1 mole. If they are asking molecules, that is in the second question, we can solve this. Now so question number B. So they have asked how many molecules. Now 1 mole of S8 contains 6.023 into 10 to the power of 23 molecules. First we are calculating molecules, so I have written the molecules. How many moles you have? 0.02 moles. Take it as x. Cross multiply, what we get? X is equal to 0.02 into 6.023 into 10 to the power of 23. So this should be your number of molecules. Now one more important thing, 0.02 can be write like this, 2 into 10 to the power of minus 2 into, this will be 10 to the power of 23 into 6.023. So this 23 minus 2, so 2 into this we can take as such. If you want to write exact value, 6.023 into 2 into 10 to the power of 21. Hope you are able to understand. 0.02 I have taken as 10 power minus 2, so that this easily you can solve. 10 to the power of 21. Now multiply this, 3 to 6, 2 to 4, 0, 6 to 12. So we have 12.046 into 10 to the power of 21. To write in the scientific notation, I want 1.2. Therefore, 1.204 you can take. This is the exact answer, 1.2046 into 10 to the power of 22 molecules. So this is your answer for molecules. Hope you have understood this. Now, how to find out atoms here? So if you identify this, 1 mole of, or you can say 1 mole, or you can directly write this as 0.02. 1 mole of, or 0.2 mole of S8 contains 1.20, we can write it as 5 also, 1.205 into 10 to the power of 22 molecules. Now they are asking how many atoms are there. In the second part they are asking how many atoms. So we know here single molecule has 8. So therefore number of sulfur atoms. How do you calculate number of sulfur atoms? Take it as into 8. So you know this. So we can write like this. 0.2 mole S8 contains 1.2 into 10 to the power of 22 into 8 atoms of sulfur. Hope you have understood this. Very simple. 1 molecule of sulfurate, that is S8, contains 8 atoms I have written. Therefore, if you are writing like this into 8, so what will be your answer? Then 8 ones 8. So 9.6 into 10 to the power of 22 atoms. So number of sulfur atoms. Hope you have understood this very simple calculation. So with this we have completed question number 22. Let us move to question number 23.